So in this video, we are going to look at this second inequality and solve that one. So again, we're faced with an inequality that has absolute value, but the absolute value is not all by itself. So our first thing is to concentrate on getting this all by itself. So I'm going to try to get rid of this plus 5 and try to get rid of the times 3. So the first thing we're going to do, remember we're unwrapping that present, we're going to do the order of operations backwards. So we're going to subtract 5 from both sides. That's going to give me 3 times the absolute value of y plus 7 is less than negative 21. Now you may be tempted to stop here and say, well, that's negative, so this is one of those special cases. But you cannot make that call until you also get rid of this 3. The reason is because if this had been a negative 3, just pretend with me for a moment, and we divide both sides by negative 3, that would leave me with the absolute value of y plus 7. Remember, I've got to flip this, is greater than 7. And so you see, once I got that isolated, this number is no longer negative, so I could move on. However, that's not what we were faced with. What we were faced with, remember, was that 3 was positive. So I do need to divide by 3, and that's going to give me the absolute value of y plus 7 is less than negative 7. Now I need to stop, now that I have this all by itself, and ask myself, is this number positive or negative? And in this case, it is negative. So now I need to ask myself, is this less than or greater than? If it's less than, what do you think the answer is going to be? So think about it. If you take the absolute value, you're going to get a positive number, regardless of what's inside here. And a positive number will never be less than a negative number. So the answer is no solution. If it had been greater than, so if the inequality had been greater than, well, if you think about it, what would the answer be? No matter what I plug in here, when I take the absolute value, this side is going to be positive. So when is a positive number greater than a negative number? Every time. So this would be all real numbers. So if you have a less than, it's no solution. And if you have greater than, it's all real numbers. So just to back up here, it is very important. I think the things to take away from this is, first and foremost, isolate this absolute value part, then stop and ask yourself, once you have it isolated, do I have a positive or a negative number? If you have a positive number, you keep going. If it's greater than, you're going to take what you have, and then, or the second case would be less than the negative. If it had been less than, then this would be the same, but instead of or, you would have and. So 6x plus 3 is either less than 3 and greater than negative 3. That would be the in-between case. And the or is the either side. If what you have on the other side is negative, the answer is either going to be all real numbers or no solution. And the way to know that is which way this inequality faces. If it's less than, it's no solution. If it's greater than, it's all real numbers. I hope that clears up absolute value equations. If you still have questions, don't hesitate to reach out.